So today is this. Have you heard of scientific notation before?
Yes.
No.
No?
No.
Never.
Ever.
Okay. It turns out that as science got better, numbers got bigger. Because as science got better, particles got smaller. And distances got longer. Because we could now measure distances between planets. We can now measure the weight of an electron. So the numbers got humongously big, to the point that they either have too many zeros to make them really, really large, like the distance from here to, I don't know, Saturn, or they got really, really small with a bunch of zeros after the decimal point, like the weight for an electron. So scientists had to come up with a way of making those numbers smaller so they could be easier to work with. And what they came up with was scientific notation. So, Johan, what is a short way of writing this humongously large number?
According to scientific notation, it is.
That's how many zeros that one has.
Wow.
Oh, you put the infinite.
Exponents.
Okay, listen to my question and answer it. How many zeros does that one have?
18.
18. 3, 6, no.
No?
19, yes. So, a way of writing this is 10 to the 18th. Because this means 10 times 10 times 10 times 10 times 10, 18 times. And if you notice, 10 times 10 times 10 times 10, for example, would give you what?
1,000.
Huh?
1,000.
10,000. And if we use this method, this would be 10 to the 4. Very good. Is that part clear?
Yes.
Okay. Now, let's take it a step further. Let's say that this is no longer a 1, but a 2. Would this still be true?
No.
No.
20.
22.
But 2 times this would be true, wouldn't it?
Yeah. No. Yeah. Yeah.
Yes or no?
Yeah.
Yes.
So what if this was a 3?
3.
3 times 10 to the 18.
So how would I write 30,000 in scientific notation?
3 times 10 to the 4.
Very good. I think you get the hang of it. So how would you write 55,000 in scientific notation?
5 times 10.
Very good.
I know what to do,
You
but
get the hang
Oh,
of it, right?
so that's what it says in the calculator. Wow.
Ah, that's exactly what it says in the calculator. Yes, Leah.
Don't you have to put the parentheses though?
What parentheses? Where?
In 10 times 10, yeah.
Instead of the times?
Yeah.
No. I know I always tell you to write parentheses for times, but scientific notation is written with an X. Okay, so in this case, no. Hold on, we're not done yet. I need you to see something else.
But miss,
Well,
how
yes.
do we write it in the paper, like organized?
Ah, so what are they going to ask you? Let's say, so let me take this a step further. May I?
Yeah.
What if I have 72,000? How would you write that in scientific notation?
72 times 10 to the power.
70 times 2 times 10.
Okay, that's one way. But there's a little, that is not incorrect, that is true. But there's a little bit of a rule. And the rule, Sir Kike, is you have to have one single big digit, and the rest you can put as decimals.
So 70 times 2 times 10
Almost.
times 3? Oh,
How
2
about this?
times 3. Oh.
Did I confuse you all? Did I confuse all of you?
Why 4?
I'm confused.
Okay, why 4? Excellent question. I have a question. Yes, Alicia.
I know the answer what it's for. Yeah, me too, because
Why is it 4?
because of the decimal point.
Because of the decimal places. But let me put it to you this way. What if you have 110? Isn't this 1.1 times 100?
Yes. No.
Try it with your calculators.
Yeah.
It is, isn't it? So, this could be 1.1 times 10 to the 2. And like Alicia said, you've got 1, 2 places after the 1, right? 10 to the 2. So how would you write this one?
Makes sense now.
7, 0, 24. How would you write it in scientific notation?
7.0
7.024 times 10 to the what?
10 to the
3, 2, 3.
3.
You've got 3 here and 3 here.
10 to the
6.
Yes,
Is that clear?
Yeah.
yeah.
Yes?
Yeah.
No?
No.
Let's do another one. How about 476 in scientific notation?
4.76
4 times 7
times 10 to the 2. Wait, why 3? 2. Wait, why is it 2?
I get
it
it.
now.
To the 2.
Wait, so you put
Because you count you count the number of places after the whole number.
Okay.
So this is 1, 2.
And what was in the first one 4 again?
And
This one? Because you've got 1, 2, 3, 4.
Oh, okay.
yeah.
Okay? May I make it just a little bit harder?
Yes.
Now that you've gotten it?
Now I get it.
How about this one? That one has a decimal point. Does that make a difference?
No.
It's not. I don't think
4.7624
Oh, this one.
times 10 to the?
To the 10 to the 4. The 4. To the 5.
If I do it to the 4, this
To the
becomes a 47,624. Is that what I
So
have?
they have to go with the 2.
By the 3.
The 2. These 2 don't count
So why don't they count though?
because they're after the 0. They're after the decimal point. So
So you count from the decimal point.
yes, you count from the decimal
So-
point to the base to the number you're gonna leave by itself.
And
Yeah.
if that 24 becomes like a 50, does it become, it's still the same?
So what would this be? 276, 82.13. How would you write that in decimal in scientific notation?
2.7682 times 10.
Right? Times 10 to the?
To the
1, 2, 3, 4, 5.
To the 4.
Oh, so I kind of wrong.
1, 2, 3, 4.
Okay.
Is that clear to everyone?
Yes.
Yes. Okay. Stop the video now and start a new video because we're going to do the same thing but with smaller numbers.